Yeah, we have the main thing is that we haven't seen that Girly is going quite down in terms of performance of the validators. Like many people are shutting down their machines, many services are starting to go down, and we see also that obviously many show that the node was not performing very well on the latest release, so they decided to shut down their nodes. And since they are registered and they had key shares, now many of the machines, even if you upgrade, are not performing great. So this should be solved in the next release. The idea here is to launch two versions of Husky. So the next Alpha 6 will be already launching Husky. And then we will launch the one that is primarily a new rewriting a smart contract with new everything like recreated with a new version of the client, the so-called Alpha 7, also in Husky. So there will be two, you can call it two testnet in Husky, but the next one will be already in Husky, so you can forget about Guerli after that happens. Another change that we'll probably introduce is that by default, we are going to use Nimbus because we have an API integration that they have developed with us. So Nimbus will be the default client, no more Prism, and try to go more towards the diversity of clients as well. Geth will still be there for the moment, but we will get rid of it as well. So for the moment, the preferred options will be those.
Maybe we can share some news about Holoski, the new features we're going to enable there. For example, collateral for node operators will be there. That I think will also help on the performance because right now in Goerli we are having, as you guys know, issues with operators shutting down the nodes, and that's because mainly it's free, right? So yeah, in Holoski we expect to have much better performance also for that, and also it will be the experience itself. It will be much closer to mainnet, and yeah, basically that's I mean the biggest features we are gonna start with.
The next release, Alpha 6, is already Husky. I think, if I'm not mistaken, but Franjo is much more deep into the timelines of this. I think it's being tested right now, no, Alpha 6. So after we finalize testing, it will go out and we will do it in Husky. So we'll update all the structure on how to run the node, how to run Husky on the Diva AlphaNet repo. And yeah, the next one, hopefully next week, potentially. I would say, but maybe Franjo can comment on this.
Yeah, we're testing Alpha 6 already. We're also need to we will have an all kind of new scripting for the Holoski. As you guys know, this is starting from scratch basically. But also wanted to ask you for please do not turn your notes off for Coerly. I know we know it's kind of dead, right? But we have interesting states there that we are tracking and we are studying. Wouldn't like to lose that, but if so, of course, the next release will be Holoski, and the Alpha 6 we are testing it internally, and probably the next public one will be Alpha 7. But wouldn't give a date for the public release. We also, since in Holeski we are starting from scratch, we have put in place different quality measurements for the new releases to be more to be better experience. Yeah, so I wouldn't I wouldn't give a concrete date on that.
Yeah, and regarding the metrics, yes, we are doing a redesign of the Staker UI that is currently finalized, but not integrated with the client. So the client also needs to provide a few more API endpoints to fit the new operator UI. So there are more metrics, few diagrams, pulse pages, operator pages. We rely, by the way, on now that Peteris joins, we rely on the DivaScan Explorer to basically extend any information that is not important for the user. So if the user wants to see any pool that is not participating on, there will be a link to DivaScan so people can click and see who is part of the pool and explore all the details that you can see in DivaScan instead of trying to make too crowded the operator UI. But at least a minimal amount of information about how your node is performing, the uptime and so on will be shown, yes. Uh, it's a combination of many factors. I think Gurley had a long queue some days ago. I don't know if that's the case anymore, but one factor could be that, and the other is that, well, if people are not depositing enough Gurley Ether to the staker contract, no validators are created. So Ethers need to be deposited for validators to be created. So if we don't have enough, then no validators. As soon as we find some time, I think that we are spending most of our time in the development trying to achieve as much as possible, and having ERM is more like a nice to have than a must have, and we have so many must have that is currently not prioritized, but I see a lot of emphasis and interest from the community. So all right, I know, and I keep it in my mind, in the back of my mind to prioritize it more, like as much as we can. But we'll try. We'll try. I cannot promise anything on when, but for sure before mainnet. It is. It is. I have the Nano PC in front of me to remind me every single day. So no worries, guys. It's around. For the moment, we have a basic rotation already. So the aggregator is rotating every single time. But there is no detection of when an aggregator goes down. So since one node that needs to aggregate all the signatures, you could have all of them aggregating the signature, but then you can have splitting of the network. Like you can have people that aggregate with one person, people that aggregate with the other person, and then you can have liveness issues. So the idea is to have only one aggregator where everybody communicates, and the problem is that that person can go down. So in case that happen, right now we don't have anything implemented in the current version of the testnet, just this simple rotation. But I think it's coming for the Alpha 7, not for the Alpha 6. For the Alpha 7, it will come the full consensus implementation. It's already partially developed. It just needs to be finalized and fully tested.
I find the last question most reasonable. I just wanted to ask: are there any basic? What's the basic design? What's like the basic assumption for this mechanism? Like, we would be probably all interested in basic rules related to availability and stuff like that.
So here the idea is that, okay, to give you some insights about the reasoning behind this. There are many ways of designing a consensus protocol, but generally it all comes to how fast can you decide who is the leader and who is not the leader. So basically consensus protocol is just like a voting mechanism to decide who is going to be aggregating, who is going to be the leader. You can do that in many ways. You can either do it sequentially to reduce the amount of communication complexity. So one communicates to the other, sends to the other, and basically that way you aggregate the voting, and you can do it in parallel. So all the consensus protocol tend to focus in one way or another. But the problem is that focus is mainly about when you have a big cluster, and then you have something like a blockchain where the goal of many of the consensus protocol is just to end up with certain consensus no matter what and always progress. But here there is a much more important factor, which is latency. We need to be fast, because if you are not sufficiently fast, you are not able to provide a signature and therefore to submit a valid proposal or a valid attestation or something like that. So the idea here is that there will be a de facto structure of a deterministic order of who needs to be aggregating. But in parallel to that, on the peer-to-peer network, we are going to be deciding who should be the fallback mechanism, who should be an alternative aggregator. So everything should be deterministic, so that no one can manipulate who is going to be the next aggregator, similar to what you can find in algorithm protocols or Ouroboros or something like that, where you have a random deterministic algorithm that chooses the leaders. But at the same time, you have something running on the background where the nodes can come to consensus and change that determinism based on the votings. So that's basically the process we are taking. That way, the first path, the path of everything is ideal, nothing is broken, tends to be very fast, and where latency tends to come is only on the scenarios where that perfect path fails and you need to jump into the not that perfect path. So yeah, that's basically the approach that we are taking.
Thank you. Well, the last part was most interesting, to be honest. But just tell me, what's your best guess? How long I could be offline to suffer no penalty or ejection? Out of curiosity,
okay.
like I'm planning to be 100% online, but yeah, just out of curiosity.
I was gonna ask you that, like, are you really thinking on being offline? So
yeah, you know, sometimes I need to upgrade my kernel, for instance, or I don't know, perhaps I will host some different stuff on that node, like L2 or I don't know, just different stuff.
And the different problems here, right? So if you cause a damage to a validator, so basically by being offline, you make a validator go offline, there's going to be a real damage to the validator. And that real damage cannot be, let's say, not tolerated. I don't want to sound like too harsh, but exactly. But you need to transfer the damage. But if there is no interruption and you just go offline for a certain period of time, there will be a tolerance. We haven't defined yet what kind of tolerance, but it's a trade-off between, if you have too much tolerance, then you have what are called lazy validators. Someone that just, set up a node and forget, because if you're 100% tolerant, then why should I run a node? I'm part of a node and then get the revenue because everything is socialized. And the other extreme is you are 0% tolerant. If you go down a single attestation, will penalize you. Something in between those lines is what I think DBT should be, because otherwise you don't have any benefit by being split into multiple nodes. You should be able to tolerate these kind of failures without being too harsh. So I think it will be like in the order of a couple of hours, but we are still defining that. So that shouldn't be a problem, I think, in terms of update or migrations or things like that.
Thanks. Can I ask just one more, please?
Of course.
I was just wondering, in a hypothetical scenario when one of the cluster members would need to be ejected because of being offline, would his key share could be somehow transferred to another operator, like in a random way or whatever different way? Or I think you know what I mean, because
I know what I mean.
Like this is a cost in many ways.
So transfer of key shares, no, there are two main ejection mechanisms. The one that will be in mainnet, because I think we won't have time to implement the other one, will be pure exits. If someone needs to be ejected for the moment, even if it's not the most efficient, you need to eject, exit the validator, and recreate it with the same set except for changing one. That is the simpler way because it's just an exit and recreate. But it's not the most efficient because you're exiting validators just to kick back one person. So the one that we are targeting for is the resetting. And the resetting, you basically you don't transfer the key because the people that had it before could still have it, right? You don't guarantee that that key has been deleted. So the way the resetting is done is that you run something like another DKG where everybody participates except for that person. So that person, that key virtually becomes kind of invalid because the group is now something different, and every single key of everybody changes. Everybody ends up with a different key, including the ones that were before on the validator. The only difference is that still the aggregation of these new keys behaves as the old keys. And you end up with the same result, with the same public key, the same signatures, everything seems the same way. There is a limitation though to the number of resettings that you can do, which is, well, if you have a 2/3, let's say we're using the 3 out of 5 as we are using currently in Diva. If you have a 3 out of 5, you have a maximum number of people that you can kick on the resetting. And that number is 3. Because if you kick 3 people that were on any of the initial sets, that they were all together on the same set, even if you have changed the rest, you have now 2 sets that could potentially have key shares that aggregate to the same result. So you could have 3 that are now out, but these 3 can come to a total threshold of 3 out of 5 and therefore reconstruct the original key. And the other 5 that are now part of the resharing can also do the same. So that can create clashings because now you have 2 groups with the same total key. That's the main limitation of resharing. But we will, like, the smart contract will keep control over that, over those limits. Was sufficient answer?
Yeah, thank you. Super interesting stuff. I can't wait to see how it works in practice. Yeah.
It's harder
Thanks.
to do in practice than
Yeah,
in theory.
I bet.
Thanks.